In today's lab, we will be looking at joining sets. So here we have two sets and we will be looking at them using the union function to join them with the union function or also with the pipe operator. So what does joining set actually mean? So remember, sets are unordered unique values. So you could have a set with value of red and blue and you join them, and that means by joining you are combining the values. One thing to note is they are unique. So sets only contain unique values. So duplicates are removed automatically. So the blue that we have here, the blue will become one blue. So if we take a look at this example over here in code, you can see we go red, green, blue, and another set here, set B, which is blue and yellow. So the blue over here is repeated. So when we use the union function here, we are calling it on the first variable. So on colors underscore A. So when we call the union operator there, what it will do is it will merge it with the second variable we have here, which has a set. So when we print this, then what you'll see is we've got green, yellow, and only one blue, and then a red. So this blue over here, these two have been merged because sets only do unique values, and automatically they will remove duplicates. Now, if we look at the pipe operator basically does the same thing as the union. This is the alternative syntax. You can use the pipe operator if you want, or you can use the union. So the union will create a new set as we saw. So we had to put a variable here and that will create the set. Original set remains unchanged. So these two sets remain unchanged because you can see it will return this function here, returns a new set. So we do not amend the existing sets. So results are stored in a new variable. So here, the pipe operator basically means it's a union. It's just a shorter syntax. You can, if you prefer to use this one or the pipe operator one, the choice is up to you, whichever you like. And it will give you the same results as the union function. So the pipe operator basically does the same thing. So if I run this, you can see that we basically get the same output as the union operator over here. So there is no difference. So you can use a union or pipe depending on what you like or which one is more clearer to you as to what the code is doing. There are multiple ways of joining sets. So here you can see that you can use the union function. You can use the pipe operator, which basically does the same as a union. So pipe and the union function are the same. Or there's a third one which you can use, which is the update function. So the update function looks like the union function, but there is one important difference. So first, joining set means, remember, sets contain unique values. So red and blue here, when you combine them, then what will happen is if you have another set with blue, then only one blue will be retained. So duplicates are removed automatically. So by using the update method, what it will do is it will update changes to the original set. No new set will be created. Duplicates will still be removed. So here, what we'll do is we will run this line over here to populate our two variables here with the sets here. So the set contains red, green, blue, and blue over here and yellow. Notice that blue is repeated blue over here and here are repeated. So when we run this over here into the variable A, so colors A dot update and takes the input of colors B variable. So that's color A and color B variables. So we are calling the update function on the variable A. So it will modify this one directly. So if I run this, and you can see that it has changed the variable colors A and merged set B into it. So now we have green, yellow, which is from the set B, blue and red. So colors have now been modified. So the update adds values from the second set directly into the first. So here A got the values of B, which is, you can see B had yellow. Hence, we have yellow here. The blue was repeated, so it only keeps one because duplicates are removed automatically. Now, you might then wonder, why would you have two operators, union and also the update? So update, as you know, modified the original set. Union, what it does, it creates a new set. So statement like this, union of that. And as we saw in our example, when we do union, it takes in a parameter. This parameter is the second set, and then it gives you a new set back, which you can store in a variable. And the pipe operator is just an alternative syntax to union. So you can use the pipe operator. There is no alternative syntax for the update one. So there is no shortcut operator that you can use shorthand. So update will modify an existing set set like this, it looks very similar to the union, but actually it does a different thing. You can see there is no variable name mentioned here, while over here you do have a variable here before the equal sign to give you a new set. So sometimes you will want to have a new variable, keep the originals intact, but sometimes you will actually want to modify an existing variable, so use the update method over here. In this lab, let's take a look at how to use the intersection function and the intersection operator. So here you can see we have two sets, morning tasks and afternoon tasks. We want to combine them and only keep the items in this set that match. So meeting here matches against the meeting there. So we don't want to keep email, coffee, or report because they don't match with each other. So remember, what does combining or joining set actually means? It will keep unique values. So if you have a set with red and blue, when you combine them, it will automatically remove duplicates. So if you had blue plus blue, then it will only keep one blue. So here we have this one, meeting plus meeting. So we only want to keep one of these meetings. So you can use the intersection method over here or function. And here you pass it the afternoon tasks, and then you store that in a variable called shared tasks. So if I were to run this over here and run this, you can see by doing an intersection, it's combined the meeting over here and meeting over here because it exists in both, and it's given us output of meeting. So basically you can think of it as it's shared values only. So values that exist in both sets. So in this case, we had meeting, and then we got the output of just meeting. All the others were discarded. So email was discarded, coffee was discarded, and report was discarded. And it kept only the matches. Non-matching values were removed. So only meeting was kept. You can use a shorthand or a shorter syntax for this one, which is the AND operator, which basically does the same thing as an intersection. So here we are going to combine the two sets, but using the AND operator. So it will look for where values exist in both. So meeting and meeting. So again, if I run this, you can see only meeting is kept. So we still get the same output. It is your choice whether you want to use the intersection function or do you want to use the AND operator. You will still get the same results. It's just the AND operator is shorter syntax, but it still means it's an intersection. In this lab, we'll look at the intersection update method over here versus the intersection method. So notice the intersection gate method has underscore update here, while this one, it doesn't. So what's the difference? Before we do that, let's take a look at what does joining set actually mean. Joining set means that only unique values are kept. Remember, sets are unique values. So here, duplicates are removed. So if you've got red, blue, and if you had blue plus blue, then only one blue would be kept. So in this instance, if you look at our morning tasks and afternoon tasks, we have meeting in both of them. So if we have meeting in both of them, intersection means we only want to keep the tasks that are meeting tasks and not email, not coffee. But because there's two of them, when you combine them, it will remove the duplicates automatically, but only keep where they both exist. So in the morning tasks, meeting exists, and in the afternoon task, you can say meeting exists. So the intersection operator, this one, will give you a new set back and you can store it in a variable. But the intersection update method, it actually modifies the morning tasks variable. So it modifies the original, while the intersection one over here gives you a new set that you can then store in a variable. So here, if I run this over here and run this, you can see we now have a new variable shared task. And when we print the shared task, we get meeting. But when we use the update method here, notice that we're calling it on morning tasks. So it will modify the morning tasks variable and remove all the other ones where they don't exist in both sets. So updates the original set, keeps shared values only. So shared values, which was the meeting variable, and then no new variables are created. So here, no new variables are created. Only the intersecting or the ones that are shared are kept. Notice here, the intersection method here has a shorthand, which is the AND operator. So the AND symbol over here, which basically does same thing as the intersection method. So it gives you back a new set that you can store in a variable. There is no equivalent of the AND operator for the update method. So you have to use the update method. So there is no shorthand. So use intersection when you want a new set to be created that you want to store in a variable, and use the intersection update method when you actually want to modify an existing set. So depending on the situation, if you want to save on memory, if it's a large set, then of course the update method would be better. But if you don't want to switch or modify your existing sets, then creating a new set with the intersection method may be better for you. In this lab, let's take a look at how to get differences of Python sets. So here you can imagine you have an online airplane booking system. So you've got available seats A1, A2, A3, A4. and then you've got people who have already booked seats, so A2 and A4. So what you want to do is you want to now find out which seats are still open from the original available list. So on the plane you had this capacity and the people have booked these 2 seats. So how do you find the differences? So these would be differences. What I mean by that, differences, values which are not shared. So values that are unique. So they must not exist in the second set and only exist in the first set. So here you can see that we've got the variable available seats. We are calling the method differences on it and passing it the booked seats. So this is the one that contains basically the duplicates. So A2, A4, A2, A4. So we want to know unique values that don't exist within this set. So they must not exist in there. So here, if you run this, you can see you get the values A3 and A1. So A3 doesn't exist in this and A1 doesn't exist in this as well. So left side matters. So the reason we've gone with the left side here, so that means that available seats is the one that you call it on, not on booked seats. So this basically, the left side must contain all the values and the other side is where you're checking are there any duplicates. So matches are removed and you are given a new set that you can store in a variable. So we are only left with only seats not booked remain. So these seats A1 and A3 have not been booked and are still available for booking. So these are what you might say are open seats. So you can use a shorthand operator, which is the minus sign here on the left hand side. Remember, left side is important. This contains all your data set, and here is the one that contains duplicates that you want to remove. So you want to remove duplicates from this data set and store them in a new set or variable. So here, when we do this, you can see we get the same result, A3, A1, A3, A1. So by using the minus sign, it just basically means it's same as the difference method, but it's just a shorthand. So it does the same behavior, but remember, it takes the values from left hand side. So it reads from left to right. So that means it will keep the unique values from this set while considering any that are duplicates in there. So if there are duplicates in there, it will remove them from this one and then put them in a new set for you. So you have the short syntax or the method one. You choose which one you like the most or is easier for you to understand. Both do the same behavior, and that's all that you need to be aware of. So here we have a set where we have on-site staff and remote staff. And what we want to do is we want to keep in these 2 sets people that are unique to each set. So we want to keep Alex, Jordan, and Taylor. We don't want to keep Sam because Sam works on site and also remotely. So symmetric differences are not shared. So they are not shared in multiple sets. So we're looking for value in either set. And remember, duplicates are removed. So we had duplicate here and duplicate here. So duplicates are removed. So symmetric differences keep the values that are not shared. So if I run this over here and then run this, and you can see that we've got the values Jordan, Taylor, and Alex. So Alex from on-site staff, Jordan from on-site, and Taylor from remote site. But since Sam works remotely as well as on-site in the office, we do not want him. So that's why Sam had been removed by using symmetric difference. This method is called on the on-site staff, but you can call it on either. You could call it on remote site too if you wanted. And the new set that you get back doesn't amend the original sets over here. You can use the alternative syntax, which is this caret or the hat symbol. So the caret symbol operator, it means symmetric differences. So basically it is equivalent to this function. All it is it's a shorter syntax that gives you the same results. So we will try that. So on-site staff, remote staff, and we're going to run this and we get the same output as before, Jordan, Taylor, Alex. And you can see that we put on-site staff on the left and remote on the right, but the order doesn't matter. You can swap them around. So just remember, use the short syntax. It means symmetric difference. It means the values that are not shared. So basically Sam is shared, so Sam gets excluded. So I hope you now understand symmetric differences. You might be wondering how is it different to differences versus symmetric difference. With differences, what it does is it looks at the list on the left hand side, so this one, and if there are repeated values in this second list, those are taken out from the first one here. So this set will only contain values that are not repeated, but the major difference is it will not give or keep this value. If I run this, you will not get A9 because A9 doesn't exist in the first set. So there you go. It just says available A3 and A1. So A9 doesn't appear. While with symmetric difference, as you saw, it also brings brings values from the second set, while the difference was 1 doesn't bring the values from the second set. And that's the method name, and that's the shorthand for differences. In this lab, let's take a look at frozen sets and what they are. So here is the syntax for frozen set. You use frozenset class over here and open parentheses. So this is the initializer for it. In this initializer, we are going to put a list. So this is a list because we know it has the square brackets separated by commas. And then when you run this, you basically get a frozen set. So a frozen set is a set that cannot change. It's known as immutable. So you cannot mutate it. The main thing with it is items cannot change or be added or removed. So here, if we take a look at our code, this is a normal set. So we're creating a normal set called cat and dog items in it. And then we're going to do a frozen set. Notice you can use the frozen set and pass it an existing set or a list. So you can pass it a list or a set. So here, if I run this, you can see that this is a normal set. The frozen set appears with the word frozen set and then open parentheses, close parentheses, and then the 2 items. So you can see that it does contain, because of these curly braces, it is a set. So this is a set, and that's a set. So the item cannot be added. It is useful when you want the data to be fixed. So you do not want data to change. So you can think of them in Python. They are frozen sets or normal sets, but locked. So you cannot change anything. And we'll prove that here. So you can see I'm going to try and add next animal in here called mouse. So if I run this, we will get an error. It says here that the add method or attribute does not exist. So we cannot do that. But with a normal set, as we know, so we created 2 sets here, animals and frozen animals. But with animal, you can use the add method. But with frozen set, you cannot. So if I run this, you can see that this has executed successfully. And we've got the 3rd animal, which is a mouse. So we had cat and dog, and now we got mouse. But with a frozen set, we couldn't do that. We've got an attribute error to say the add method doesn't exist. So you cannot do add, remove, because Python will raise an error, which is what we saw over here. We just got the attribute error. The add doesn't exist. But what you can do is do things like search. So you can loop through items, check membership, use set operations. So here, for example, I can check is cat in the frozen animals. So cat item is in frozen. It is true. So that works. And we can also do set operations such as intersection. So if we had 2 frozen sets over here, then we will know which items intersects. Doesn't exist in both, but dog does. So we should get the output of dog over here. So intersection works and keeps the dog, while cat and lion are different, so it doesn't keep them. So with frozen set, what and when should you use them? So that's when data must not change. So you can use them in those instances where you do not want like the frozen animals to change. Use as dictionary keys, and for anything where you want a fixed collection, normal sets cannot be dictionary keys, but frozen sets can. So here you can see frozen set can be a dictionary key. So we're creating a dictionary by these curly braces, and you can see key and value, key and value. So here frozen set can be the key. So we got the key read and write permissions, and the role will be editor, and we got the read permission, which is the role of the viewer. So if I run this, you can see that dictionary key is actually a frozen set over here, while with a normal set, you cannot do this. So this is when you want data to not change, use frozen set. What is a tuple? So in this lab, we're going to look at tuple. The simplest one is the creation of a tuple. So here you can see I'm declaring a variable called colors. That variable is going to contain a tuple. Tuple begins with an open parentheses and close parentheses at the end. So here you can see it's just a list of items separated by a comma. But the important thing is these parentheses. So if I run this is what you get. You can see it's indicated by these parentheses that it's a tuple. Tuple is basically ordered collection. Basically, think of it as storing multiple values. So here we are storing multiple values in one variable. So in one variable, we've got colors. We're storing multiple values. So the thing with tuples is they cannot change after creation. They are written with round brackets, as we saw over here. So these are parentheses. And the important thing is they keep the order. First item stays as first. So if you add something here, red, then red will always be first, then green, then blue. So the order will be maintained. They are similar to sets, but sets do not keep order. So here sets are with curly brackets and they do the same thing. But what you notice is the output also has curly brackets. But you cannot then do this. You cannot access the indexes with sets, but with a tuple, which is these round brackets over here. So if you put them in and then run this, and then you can access the items in a specific index. So that's an important difference. So it keeps the order. First item stays first, and then you can access like the third item. So it's a 0 index. So 0, 1, 2. So then you get the output of red and blue, red over here and blue there. You can print the tuple. So it has 3 items by using the len method, but what you cannot do with a tuple is you cannot change them. So you cannot assign a new value to a position. You can access it. Accessing it is fine, but new values are not allowed. So here you will get, it doesn't support item assignment. You can create a tuple with a single item, but remember to use a comma. If you don't use a comma, then this will not work. So if I run this over here and then print the data types, you can see the first one with the comma is a tuple, but the next one is just a string. So you must use a comma. So single items need a comma. Without a comma, it's not a tuple. And this is a common beginner mistake. You think you are creating a tuple over here, but it's not unless you add a comma. Otherwise, it will just be a string. You can loop through a tuple just like this using the for n loop. So for each item, so here you can see it's going to print the colors over here as expected. So when should you use tuples? So here, for example, we don't want the screen size to change. For our accidentally change it in a variable later on. Then for fixed size settings, constant data, and you want to prevent accidental changes later in the code where somebody could actually change the value of a variable, then use tuples. And then, for example, here we want screen size to stay fixed. So here we are just going to prevent the user from changing it. So here's somebody goes in and goes, actually, I want 720, position 0, which is that one, then it will prevent the change because it doesn't support assignment. In this lab, let's take a look at accessing tuples using various different methods, especially people get confused around negative indexing. So let's start with the basics. So here, this is a tuple. You can tell it's a tuple because of these round parentheses, and then within there, a list of items separated by a comma. So if I run this, that's a tuple created. You can access the tuple with an index. So 0 means the first item. It's 0 index based, and then say third item, which is over here, which is blue, and then you get the output of blue. The negative indexing. So negative indexing here, -1 would mean the last item. So here, when we do -1, we're going to access the last item. So if I do that, then you get the item blue. So if we go and look at our tuple over here, you see last item is blue. -2 means second from the last. So here, this is -2. So it will go, this is -1, this is -2. So we should get green. So if I run this over here, you can see that we got the green value that we wanted. So negative indexes are useful when the length is unknown. And then here you can continue to go down. So it's going to do the third and so on. And you can see we got the very first element because this is the third element over here. But one thing to watch out when you try and do a -4, which doesn't exist, you will get the index is out of range. So although you can use it for accessing the last item, because this will always sort of exist. So when the length is unknown, you can access the last item. But remember, if you keep going like this to fourth position, which doesn't actually exist, then you will get an error as demonstrated over here, tuple index out of range. Now, the other thing you can do is accessing items by range. So range, also you can call it slicing. So here, basically, you use a colon in between. You put a start position. So here, the start position and end position, and then a colon in between. So with this one, start index is included and end index is excluded. This is important, as you will see. And the result is a new tuple. So if we do this, if we access 0 to 2, so what it will do is this is 0, this is 1, and this is 2, but end index is excluded. So you will not get the blue item. You will only get red and green. So if we go down here and run this, you can see we just got the red and green, and the blue was excluded. The result of this is a new tuple, which you can of course store in a new variable. So I could easily do this. So I can store the results in this new variable, and it's only going to have these two items. So if I run this, and then if I print that new variable, and you can see that it's just a tuple. So result is a new tuple. You can also do slicing with missing values. So you still use the colon, but miss out the beginning number, and that will mean that it's going to slice from the beginning to position 2. Remember, 2 is excluded, so you want to get the 0 and 1 item, and 2 is not included, so red and green. So here we just go red and green, and again blue was excluded. So this is where you didn't specify a position at the beginning. So you can also miss out the end position. So if I run this over here, and you can see that we've got starting from the first position all the way to the end, so it missed out the red element at position 0. So omit the start, and they begin at index 0, omit the end, and it goes to the last item. So this is very common for quick selections where you just want from a certain position onwards or from beginning to a certain position. And last but not the least, but you can check for an item existing in your tuple by just using the in keyword. So here, when we use the in keyword, you can see it returns true that green does exist in the colors as we know from here.